Greetings to all. I am P. Ramalakshmi, Assistant Professor of EC Department, Kamaraj College of Engineering and Technology. Let us see about physical design of IoT. So, these are all the contents: introduction about IoT, characteristics of IoT, advantages and disadvantages of IoT, applications of IoT, physical design of IoT. So, we have an introduction about IoT. So, IoT has become one of the most important technologies over a past few years. IoT, it describes a network of physical objects and things which are embedded with sensors, softwares and other technologies for the purpose of connecting and exchanging data with other devices and receive data from the other devices over the internet. So, characteristics of IoT. IoT devices and systems may have the capability to dynamically adapt with changing context and take actions over the operating conditions and sensed environment. For example, let us consider a surveillance camera system. So, it consists of number of surveillance camera. The surveillance camera can adopt their modes like normal mode and infrared night mode based on whether it is day or night. Also, it can switch, the camera can switch from lower resolution to higher resolution when there is a motion is detected. So, self-configuring is one of the characteristics of IoT device which allows large number of IoT devices connected together for a certain functionality like weather monitoring. Interoperable communication protocols, it supports this communication protocols to communicate with other devices and with other infrastructure, and each and every IoT devices has a unique identity and a unique identifier. So, IoT devices are integrated into information network to communicate and exchanging data with other devices. So, in IoT we have advantages and disadvantages also. So, the advantages are: it minimizes the human work and effort, also it saves the time. It is good for personal safety and security, and it is useful in traffic and tracking monitoring system, and it is beneficial for the healthcare industry. While coming into disadvantages, it increases the privacy concerns, increased unemployment rates, highly dependent on the internet, lack of mental and physical activity by humans, it leads to health issues and complex system for maintenance. So, IoT application, we have numerous number of IoT applications in our day to day life. While coming into smart home, we are using gas and smoke sensors in smart cities, smart parking and smart transportation and structural health monitoring. For the case of environment, we can have air monitoring system, water monitoring system. In energy, we have renewable energy systems. In retail, smart payment system. For logistic, route generation and location and scheduling. For agriculture, smart irrigation system and greenhouse control. In industry, indoor air quality monitoring system. For health, we have lot of electronic wearable sensors to maintain and to monitor our fitness. So, physical design of IoT. So, physical design is more than creating the products. So, these two things are more important to create a IoT system, ecosystem. So, things in IoT and IoT protocols. Things in IoT. So, things in IoT, it refers to the IoT devices. Already I said IoT devices has a unique identities. IoT devices can perform sensing, actuating and monitoring capabilities. Also, it can exchange data with other devices and applications, and also it collect data from other devices and process the data locally and send the data to the centralized server and the cloud based applications. So, this is the generic block diagram of an IoT. So, the IoT device consists of a number of interfaces for making connection with other devices. So, it consists of input-output interfaces for sensors and actuators. So, for the input-output interfaces, we can use the devices UART, Universal Synchronous Receiver Transmitter, Serial Peripheral Interface, I2C, and we can give input to the sensor and get the output from the sensor by using these devices. Audio video interface. For this we can use HDMI, high definition multimedia interface, 3.5 mm audio, RAC video. So these devices are used to record the audio and video in a system. So processor, CPU, central processing unit is used to process the data, and graphics, GPU processor. For the connectivity we can use the USB host and RJ Ethernet cable for making connection with the device and the server. Memory devices and storage interfaces we have. So SD, MMC, SDIO, it is used to store the generated data from the IoT device. So connectivity, processor, audio, video interface, input, output interface, storage interfaces. IoT devices, it can be of varied types. For instance, wearable sensors, smart watches, LED lights, automobile and industrial machines. All the IoT devices can generate the data in some forms, or otherwise the data generated from the IoT which is useful for guide some other functionality. Then IoT protocols, it is used to establish communication between a node device and the server over the internet, and also it can send the comments to the IoT device and get the results from the IoT device. For this we can use number of layers like application layer, transport layer, network layer and link layer. So IoT protocols, here we are going to use 4 layers. In normal OSI model we have 7 layers. So the 4 layers are link layer, network layer, transport layer and application layer. So the link layer is used to establish the connection between here we are using 4 layer protocols, that is link layer, network layer, transport layer, application layer. So in the link layer we have the number of protocols like Ethernet, WiMAX, Wi-Fi, LRWPAN and mobile communication. In the network layer we have the protocols like IPv4, IPv6 and 6 low WPAN. For the transport layer we have 2 different protocols, that is TCP and UDP. So for the application layer HTTP, COAP, WebSockets, MQTT, XMPP, DTS, AMQP. So the link layer protocol. So the link layer protocols determine how the data is physically sent over the network's physical medium or layer. So the mediums are copper wires, optical fiber cables or electrical cables. So let us look at some link layer protocols. So first one is IEEE 802.3 Ethernet. So it is a collection of wired Ethernet standards. We have here we have wired and wireless protocols we have. So it is a wired protocol. So we have number of standards like 802.3 I, J. So for these protocols are use some different mediums. For 802.3 we are using coaxial cable as a shared medium. 802.3.I we can use copper twisted pair connection, and 802.3.J fiber optic connection. These standards provide the data rates from 10 megabits per second to 40 gigabits per second and more than that. So this the shared medium already I said, it can be a coaxial cable, twisted pair wire and optical fiber. So another one link layer protocol is IEEE 802.11 Wi-Fi. So it is also a collection of wireless local area network communication standard. So here also we have number of standards with their operating frequency bands. So it provides the data rate from 1 megabits per second to 6.75 gigabits per second. So another standard IEEE 802.16, that is WiMAX. It is a collection of wireless broadband standard. Here the operating data rate from 1.5 Mbps to 1 Gbps. And 802.15.4, it is a low rate wireless personal area network. Here the data rate from 40 kbps to 250 kbps, and it is specifically for the low cost and low speed communications. Then we know the mobile communication standards, that is 2G, 3G and 4G. The 2G including GSM and CDMA, and 3G including UMTS and CDMA 2000, and 4G we have LTE. The network or internet layer. So, this layer is responsible for sending the datagram from the source network to the destination network. Here it performs host addressing and packet routing. So, for the IP addressing, we can use IPv4 and IPv6, that is Internet Protocol version 4 and version 6. The version 4 it generates 2 power 32 addresses, and IPv6 it generates 2 power 128 addresses. 6 LOWPAN. So, it is nothing but IPv6 over a low power wireless personal area network, and it brings in the IoT protocol to low power devices with limited processing capability. So, transport layer. So, it provides end-to-end message transfer capability, and it is independent of networks, and it supports the functions like error control, flow control, congestion control and segmentation. So, for these functions we are using two type of protocols, that is transmission control protocol and UDP, user datagram protocol. So, transmission control protocol it is a connection oriented protocol, and it ensures the reliability of packet transmission as well as it ensures the error control, flow control. So, it is the widely used transmission control protocol. So, UDP it is a user datagram protocol, it is connectionless protocol. It is the main application of this user datagram protocol is time saving applications. Then application layer. So, these application layer protocols define how the application layer interface with the lower layers to send the data over the internet. So, here some of the application layer protocols are listed, that is MQTT, that is message queuing telemetry transport, HTTP hypertext transfer protocol, COAP constrained application protocol, WebSocket protocol, it allows full duplex transmission, and TDS data distribution services. So, this protocol enables process to process control over by using the ports. In this lecture, we have seen about what is IoT, the characteristics of IoT, applications of IoT, advantage and disadvantage of IoT, then the physical design of IoT we have discussed here. So, in the next lecture, we will discuss the logical design of IoT. Thank you.